Everyone wants to run wind simulations, and Eddy3D makes it possible. But if you don't understand each individual tool, you will struggle. Today I will show you how to set up Eddy3D, how you prepare your 3D model, and at the end how you visualize your vectors, so you can stop the guessworking and present your stuff with confidence. Member shout out. Alright, before we jump in, a very quick shout out to one of my new members, and please forgive me, many of my members have difficult names, but this one is particularly tricky. It's like a riddle. So I would say Sneha Shark. I hope that's correct. Nevertheless, thank you so much for supporting my channel. Please reach out if you have any question, and I hope you get something out of it. Alright, let's jump into Eddy3D. Now, we only looked into Eddy3D very quickly, and we only looked at the template files. Now, the template files, for some reason, what's really annoying is that they updated the software, but they didn't update the template files. It's a bit lazy, I have to say. Nevertheless, it doesn't really matter also, but just keep one thing in mind. If you don't understand Eddy3D, the templates also doesn't really happen. They don't really help you, because every project needs a bit of a different settings, depending on size, depending on objects, how many objects, depending on what you want to get out of it. And that's why I want to go through all the tools step by step and really explain what they do, so you can go out and do your real wind analysis tests with confidence. Now let's jump into, I don't know why, panels, toolbars. Don't know why this is missing. Okay, here we are. Go back to my standard. Let's open Grasshopper. All right, we're heading over to Eddy3D here. Templates, yes, we have templates. So the templates we looked at, that was very cool because we can go here and get a template for whatever we want to test. Again, I think the Eddy3D team should take some time and update these. All right, let's throw it away and let's properly learn the software. We will look into this folder here, this drop down, and we will use a few other things, but just very minimal. It's all here. What do we need first? So just very quickly as an introduction, I just modeled a very simple terrain with a street going through, or with like a road coming up. And then we have a small village, an existing village, and then I have to add new buildings to this model. And it's a very simple massing model, but it's ideal for this stage. That's the stage where you should do wind analysis, and not when you have modeled everything. Also, just to make sure you understand, if you have a very detailed model, the wind analysis will not change much. It will actually, it maybe just slows down your computer, but the result will be very similar. The reason is that OpenFOAM is kind of simplifying your geometry on the go. Now, let's go through this. So what's in here? And what's great is that it's all organized in the right workflow. We need one of the two here. The first one is the atmospheric boundary layer flow boundary condition, and the other one is the uniform flow boundary condition. So what does that mean? And by the way, I'm getting the bifocals here. That's very useful, so you can see the name also, not just the symbol. Okay, what's in here? Wind direction. So basically what it does, it sets up your domain, the wind tunnel. So the wind tunnel will need all this information. Now this is where most people don't get it right. Don't just use defaults. Try to understand really all the inputs. The atmospheric boundary layer flow boundary condition is basically Eddy3D basically tries to simulate a real wind scenario. In real life, the wind or air movement will be slower, closer to the ground, and faster upwards the further it goes up, although it will balance it out. So it's not equal everywhere. So it just tries to simulate it, just to get closer to a real world scenario. So that's that condition. You can also have a uniform condition. But because we are outside, we want to test this with the atmospheric boundary layer flow. Now there's wind direction. That should be very everybody should understand what that means. And we can control this with a slider. Just put it here from 0 to 360 degrees. And I place this in here. We can't see anything. That is a bit annoying. So what I will do, I just add the domain already so you can see the domain. I will first use the box shaped domain. We can always try the other one, but that's basically my wind tunnel. And I can place this in here. Nothing happens. So I would need to add some geometry first. Okay, so we can see a bit what it does. Okay, geometry. I think you can place B-wraps into here, but what I recommend is to translate everything into meshes. Let's do that first. So I will add my buildings first here. Oops, this is strange. Okay, I would translate everything into meshes. Mesh B-wrap. That's what I want. So you can place a B-wrap in here, and we will combine the mesh, unite. Where is it? This one, mesh join. And sorry, I forgot. I also want to use the settings here, and I use the speed, the more jagged, more simplified mesh settings. Now place this in here for now. I have two because I want to place here the terrain, and I want to give you just a hint right away. For the terrain, please make sure that your terrain model is facing the right direction. So for example here, it does not for some reason. Yeah, so yes, we can turn off the preview here. Right click, preview off. Also this one. And we can place this in here. We can also turn this off if you want. We actually don't really need to see that. Now buildings go in here, and it automatically creates the domain based on the size and extent of your model. And I can also place the terrain, and it changes again slightly. Now it automatically sets a length and a width and a height, but we can control that further if we want. Actually I want, because I feel it's too big, at least from that side. So I could put here a length. Oh, not the length, the length. I don't want to change the length, I want to change the width. Yes, I think this is good. There's other things. Block size 20, I just keep it as it is. The length of the wind tunnel we just explained. There are other things here. Yes, we haven't looked at this one. There is something called the reference velocity at set reference or C reference meter per second. This is the wind speed we want to test. So if you have a data, you can use that here. And in my case, I just use a panel or panels to inform what I want to test. So in that case, I want to test, let's say 4 meter per second. And by the way, maybe I want to change my block size. Let's change the block size to something smaller. I'm gonna go here and say 5 or maybe 10. Okay. The block size defines on how this domain is divided in 3D cells, basically. The reference height. So the reference height is the level where the wind velocity was tested. So a standard height everywhere, like for example on airports where we get the most weather data, is 10 meters. So this is like a standard level where wind is tested, because wind is not tested on the ground. It would be not accurate. So that's why everybody should just think about what the standard is, so you can compare your data with other locations and with other people who did other studies or have other wind data. Surface roughness, this is a bit abstract, but basically it tells Eddy to consider the surrounding context. And the roughness could be, for example, let's say if I put 2 meters, I could imagine this is like open grassland with shrubs. And if I would now put more, it could be like the suburbs with buildings up to 50 meters, or it's in the city with buildings up to 100 meters. Then you would try to play with that. I would just keep it with 2. And the minimum set coordinates, I think this is already given. It's like default at 0. I will put here 0. This is just assuming where my model starts. Actually, here is the level here is a 0. This contour line. So I just put this to 0. Okay, this is the first big chunk we covered, and then now we need to go into the next step, which is the simulation. Later on, I will show you how you get your wind speeds and how you can color your vectors. But first, let's fix this. The simulation receives certain things. For example, here it needs to have a simulation domain. This is our domain we just set up. It also needs a work directory. My work directory is something I set up before. I will delete everything in here so we can make sure nothing is interfering. And I put this as in a panel. So I just copy the URL and place here my directory. All right. If I put this now in here and I go back to my folder, zack, everything is back. Okay. Now we need mesh settings, and the mesh setting is not the mesh for your buildings. It's the mesh for the entire wind tunnel. So basically, CFD core is modeling everything into a mesh, into one big mesh. But we need to tell it how to set up the mesh. And it's about accuracy, basically. Okay, I'm gonna go here and say here 4 or 4. Yes, I think 4 is good. I want to have 4 as an accuracy for my buildings and for my ground. And I would say maybe 2 for the accuracy of the building bounding box. And then number of layers, I leave that, and I just put in the mode, I put 1. What does it mean? That means if I have 0, no snapping is happening, and if I have 1, then it snaps, but without layers. Now you think like, okay, now I understand more. Snapping is basically, imagine your comforter or your blanket, you snug it around your body. That's what the 3D model does when it tries to approximate the original mesh model. So it creates a mesh, and that snaps to the original geometry. So that's what it does, what it tries to do at least. Now go here, and then we have the run settings, and it's not running the settings, it's the run settings. This is here. The run settings, I want to place here maybe 500 iterations. That will basically allow me to see, it defines the iterations on how often it repeats the calculation. Every time it will become or should become more accurate. The writing interval I keep as it is, and then in the CPUs I put 6. That's the number which worked fine for me in the past. That you can also, it says here you can set -1. That will automatically set your CPUs -1 CPU. That's what I understand. So basically it checks how many CPUs you have and then -1. The reason is that you then be able to still use your computer. Okay, run settings, this goes here. And then the other things are just basically calculating these first, these tools, and actually running the simulation. Okay, I'm gonna just put here button. We need a button to run the mesh. And then we don't have trees yet. We will do that next time. And before I run anything here, I will set up 2 other things. One is the residuals. The residuals help me to monitor how accurate my calculation ran, so I can make adjustments if I need to. That's basically it will draw a graph for these iterations and will tell me if my analysis or calculation was successful. It also shows the accuracy at the end. So it shows how much error it's still left after each iteration, to be very precise. Okay, and then we have, yes, I want to have this one here. This is to clean the directory in case I want to clean that up. And by now, I think I should save this whole thing, save document. Okay, I place this in here. This needs basically the directory and a button as well. And now careful that you don't put it in the wrong, don't put it here, put it here, run. We'll not run this now, but if I run into an issue where I think there's something wrong, I can clean out my whole directory. All right, okay. So now we run the meshing first. It's a bit slower. I guess it's because I put 4 in the accuracy, and I guess also because I changed the block size to 10. That could be that's probably the reason why this is now a bit more slower than before. It was took quite a while. I can, by the way, turn this off so we don't have to look at this. Now I can run the simulation, and I hope this works fine. Okay, I can already see this will take way too long, so I stopped this because it crashed. I will fix this here a bit. I will actually change this back to 20. It seems like this was better. I will also change this here to 3, and I think to start off, I think it's a good idea to keep these numbers low. It will run quicker. It seems like it's way faster. Okay, that's good. Quick note, if your simulation crashes, then most of the time it is not this software's fault, it's yours, and you have to just go through, check everything, and come back and try it again. And now we can run a simulation. That looks good. If it doesn't stop right away, it means it runs through all the iterations. If it stops just right in front, it means there's something went wrong and it stopped. So basically it runs now through this 500 times. Because this ran quite well, I can actually lower this a bit. And now when we open the residuals, we should actually see, okay, that worked okay. But here it had quite a big ups and downs. That means it was not very stable, and then it became more stable towards the end. Yes, so it works, but probably we would still need to adjust this here to be more accurate. But for now, I think this is totally fine. Now, okay, now you think, okay, what now? Because we can't see anything. Yes, exactly. We can't see anything. That's why we need to show the props. There are 2 options here. I'm not sure. I think I need to use this one. Yes, this one. So it ran the simulation. Actually, all the data is already there. The probing is basically defining points where we want to make the simulation visible in Rhino. And so the big calculation is done. You just need to make it visible, basically. Okay, so how to do this? So we need the result. Okay, the result goes here. We need probing points. For that, we need a tool. It's called probing. Here we can put the building mesh. So that's why we have now a mesh for all the buildings. That's a good thing. So we have the mesh from here and the ground mesh. That basically trims out, it intersects the buildings with the ground. It removes all the areas where the building intersects, basically. And now what we could do is we could generate probe points by just going into the mesh and use this tool here, face normals. You can see generated all these like points. These are all my mesh faces, and it generates all these points on top. And these are my probe points. Now I want to make sure that I put them in the right level, slightly offset from the surface. We can do this by move geometry. Geometry is these centers, and I move them in the set direction. And here I can just use a panel if I want, and let's say 180 or 170 average face height, basically. Okay, and that I can place into my, so these are new geometry based on these center points of the faces. These are my probe points, and that geometry I can place in here. I can turn this off, I can turn this off, this. Now I need to give this a name, and it's up to you what you name that. I call it probes. Then it's called, the next one is called interpolation scheme. You don't need to put anything here. There's a default in there. Name of field, that would be if you want to change the output. In that case, we want to know the velocity, so that's correct as well. And then we just need to have a button to run this. Okay, place this in here. After you ran this, you will have an output. You again have the location of the probing points. This is the same location as this one. And you have the vectors. Now on how to, now the problem is it's still not visible. We need to make the vectors visible. So how to do this? Okay, so first of all, there is a tool in Grasshopper. It's called vector display, and the vectors, you should see the vectors here in black. Now the best way to move forward from this point is to cheat a bit. So I get this template, the templates again, and go in here and say I want to visualize the wind vectors. That gives me the whole setup I need in order to visualize the vectors. And I can delete this, and you see you have the same tool. I just want to, what I want to do though is I want to exchange here these items because they feel older. I also want to explode some of these. Okay, let's do this. I want to use mine because it's newer, it seems like, feels like. So I'm gonna get this. This is my width. I can change the width of these arrows. Now I can, then I know that they set it up, but it doesn't seem like to work properly. So I will take this. This is useful, of course, but I place this in here, and I use this same data container. Now I don't need to use this. I know what I want is this one. I just explode this so we can see what's inside. I mean, you could also go inside, but basically we just need to plug this in here, plug this in here. We can place this as a threshold, and we delete this, and that goes in here. Oh no, sorry, disconnect into the color, and then the vector goes in here. Yes, and it seems like we have to turn this off. Okay, yes, we can make this thinner. It looks a bit better, I feel. What else? Okay, if you want to know the actual wind speeds, you could get the length of the vector because we know the vectors. So there's a tool, it's called vector length, and we can place this in here, and that gives us a list. That gives us a list of all the vectors from 1.8 to around, oh sorry, no. It's they're of course in order based on the location. But if we want to know the maximum or minimum, we could sort these, for example, sort list, and we can place this in here and get this list out. Now we see all of the vector length in order. So with the longest vector, which basically represents the wind speed. This is the maximum wind speed on a site. So it's around 7 meters per second. So that you could then somehow map onto your colors if you want. You could also change the colors if needed. I also don't know why this is organized, but you could either remove some of the colors or map this so you can create your own legend to display it better in your presentation. But yeah, here we are. So now we have set up the simulation, we ran the mesh, we visualized the vectors. By now you should have a clean and accurate Eddy3D workflow. I will make this file plus the script available to download for a small fee in case you feel stuck. In some of the next videos we will go through how to set up trees, and then I hope we can turn our wind analysis in a full functional microclimate simulation incorporating outdoor comfort. If this video helped you, please like and drop me a line, subscribe, and if you fancy, check out my members section.